So welcome back to the wonderful world of mathematics. And today we're going to talk about exponents. And you see all these exponent rules, right? I'm sure you've known these or actually had to memorize them in Algebra 2. And actually you use these all throughout math, so they're really, really important. Especially this one right here. This is what we're going to focus a lot on later on today. But you'll see something like this, like when you divide them, you subtract the exponents. Well, that A means any number. You could have written an X there, but I don't like using an X for this. I would rather say A, any number. So we have a bunch of examples here, and we're going to cover them all right now. So the first one we're going to cover is multiplication. We have the same base, and what I mean by base is the number that we're raising to a power. So anytime I say base, that's what I'm talking about right there. So we have a base of A raised to the n power, n can be any number, times a to n, which is a different power than n. Or they could be the same ones. But what happens is we rewrite the base, so the base stays the same, but now we raise it to the sum of those powers. And this is the rule you have to remember, but why does it work? So let's give this a shot. Let's say we have 2 squared times 2 cubed. What does that mean? What's 2 squared? That means 2 times 2. So we have 2 times 2, and then we're multiplying it by 2 cubed, which is 2 times 2 times 2. There's 3 of them. 2 times 2 times 2. How many 2's do we have? 1, 2, 3, 4, 5. We're really just combining them. That tells you how many 2's there are, and if you have this many 2's as well, then how many 2's do you have in total? We have 5 of them. So we have 2 to the 5th power. And see, they add up together. So that's why we have to add them up. So now we're going to talk about what happens when we divide numbers raised to different powers. So what you have to do is take the difference. They teach you in school, hey, if you have something raised to a power divided by that same thing, that same base raised to a power, you rewrite it as A, that base, raised to the difference between the powers. You take the number from the top and subtract the power from the bottom. So why does this work? Let's take 2 cubed and 2 squared again. Or actually, we'll try something different. Let's say I have 2 to the 5th power divided by 2 cubed. What does 2 to the 5th power mean? It means I have 5 2's. Or 2 times 2 times 2 times 2 times 2. Divided by 2 cubed, which means I have 3 2's. 2 times 2 times 2. So do you see what happens here? Our 2's are actually going to cancel out. So all I'm left with is 2 2's or 2 squared, which is 5 minus 2. So instead of writing this out, we can save ourselves the time by just finding their difference. But what happens in the case that, what if this was flipped? What if I had a 2 right there, 2 cubed on top, and 2 to the 5th power on the bottom? Well, that means I have 3 2's on top over 5 2's on the bottom. Okay, that's fine. So what happens now? I'm actually left with, if you notice, I have 2 2's on the bottom this time. So I'm going to have 1 over 2 squared. And if you remember, well, we have to subtract these, right? So this is actually the same thing as 2, and since we subtract this one from that one, what's 3 minus 5? It's actually negative 2. So this is why that means the same thing. This is the reason why anything to a negative power is the same thing as 1 over the base to that same power. So this rule is actually the same thing as this rule, but when you have a bigger power on the bottom than you do on the top. So now we're going to talk about this one. Now notice whenever you have parentheses, so you have something to a power, parentheses raised to another power, we're actually supposed to multiply the powers. Why is that? So let's say I have 2 cubed and I'm squaring it. What does that mean? I have 2 cubed times 2 cubed. Remember what that means? When we square something, it means I'm multiplying it times itself. So really I have 2 cubes. So all I'm doing is really counting. The reason we multiply is because multiplication is quick addition. So this is going to be 2 cubed. When we square it, we can rewrite it as 2 to the 6th. You have to multiply them. And you can actually rewrite this. This is the exact same thing as 2 squared cubed, because it doesn't matter what order we multiply. So now we're going to talk about why raising something to the 1 over something gives us the nth root of that. Let's say you have 2, and you raise it to the 1/2 power. Now what does that mean? If you know math, you understand that that means the square root of 2. But why does it mean the square root of 2? The reason is because when we raise this to a 2nd power, when we square it, the square root cancels out, and all I'm left with is 2. And this, if you remember from that previous rule, we have 2 to the 2 over 2, which is just 2 to the 1st power, which is also just 2. So 1 over something is the nth root of that number. So anything to the 0 power is 1. I think this is the coolest rule out of all of them, because all the other rules, if you notice, they had a raised to the m and the result was some type of operation. No numbers at all. But when we raise a to the 0 power, we get a number. Always 1. It's really interesting. Why does that happen though? So I ask people this sometimes, and what they tell me is because anything to the 0 power is 1. Wait, did you just say exactly what I wrote but in English? That's not proving it. Actually, another thing that I'm told is, well, that's because when you multiply anything times itself 0 times, you get 1. Again, it's just reasoning. That has nothing mathematically behind it to prove it. But let's prove it. So if I have a to the n over a to the m, we know that the answer is going to be a to the n minus m. We covered that just a little while ago. But what happens when this bottom one is the same power? A to the n over a to the n. We said we have to subtract them. So what's something minus itself? That's always 0. And something to the 0 is the same thing as something to a power divided by something to the power. Well, what's any number divided by itself? It's 1. So that's why a to the 0 equals 1. And what about the case where, actually let me erase this real quick. What about 0? 0 to the 0 power, what does that equal? A lot of people will say that that equals 1 because that's the rule. Some people say that it equals 0 because it's 0. But in reality, or in my opinion, this is an undefined thing. What did we just say? That something to the 0 power is 0 to a power over 0 to the same power. So what's going on here? We're dividing by 0, and if you know math, you know we can never divide by 0. So 0 to the 0 power cannot equal 1. It's actually undefined.